Hi, this is Mr. Weisfeld. Welcome to the Toy Car Lab here in physics. Please note that all references to Tomy Toys Push'n Go are copyright Tomy or Takara Tomy in Japan. So let's get started. Imagine you're a new engineer at Tomy Toy Division, and as part of your training you have to take one of their push-and-go trucks and characterize, that is describe or measure, the kinematics. The kinematics are the motion characteristics of the truck, what its position versus time, velocity versus time, and acceleration versus time are. Why would you need to know this for a toy? Well, a couple people in particular, the legal department would really like to know that the toy is not going to be too fast to harm anyone or accelerate too fast to harm anyone. And the advertising department would like to know that if you say on your website or in advertising that a crawling baby can use this toy, then it should probably not be too fast to get away from the baby, and it should be an entertaining play experience. So that's kind of the idea behind this lab. Here's what we need to do. So this is, in a nutshell, what the lab's about. You have a tape timer. I think you might have seen this in class a couple times, but I'll describe it in the course of this presentation. And you also need to be familiar with Google Sheets, so we'll get some practice with Google Sheets. And we'll be using Google Docs to create our lab write-up. So what we need to do is take some data, analyze the data, and then present our findings from the data. Our objective. Yeah, you're not done until you have told me or the engineers, let's say at Tomy, want to know all that you've measured, position, velocity, and acceleration, and that data needs to be submitted for their verification and approval. Part of that data is going to be a graphical representation, say position versus time, velocity versus time, acceleration versus time. So those graphs of your data, and then a description of your interpretation or how you've interpreted those graphs, especially things like where values are constant, where the values are zero, and where the values maybe are linear, so constant slope. All of that, which we have been talking about in class, and as it relates to the truck, will be important. Let's talk briefly about the learning objectives for this lab. When we're talking about AP Physics 1, we're talking about certain science practices and learning objectives that are involved. So we want you to plan to collect data and to answer specific questions. So I've asked the question, what is the acceleration of the toy truck? You make a plan for getting data that will help you answer that question, and especially involved is the analysis of the data that answers that question. So when we're talking about kinematics, once again, we're describing motion. Mechanics is forces, velocity, acceleration, that part of physics that we're in right now. Learning objective 3A 1.2. A student can design an experimental investigation for an object that's in motion, and then you should be able to analyze your experimental data to describe that motion. Tell me about how your analysis went and what math or graphical representations you used to analyze that motion. Let's dig into the science practices, because science practices are big both in Next Gen and in AP Physics standards. So we want to, science practice 2, use mathematics appropriately. Science practice number 4, plan and implement data collection strategies. And then science practice 5, analyze that data and evaluate your evidence. So digging in a little bit, we're going to take some data, we're going to do some math on it, we're going to compute average velocity and average acceleration from distance. You're going to tell me what kind of averaging techniques or how that calculation went, and then you're going to tell me if that meets some estimates that you would believe for the natural phenomenon that's under study. So some time ago, we did measure the speed of these toy trucks in class, and I can remind you of that data, and you can use that data for a start of what you expect to find for this truck when you get done. You might have written down the number of truck you had just as a footnote. That's going to be important information. Science practice 4, once you've got that question that you want to solve, how are you going to get data? And then how are you going to answer that question? So what kind of data are you going to gather? I'm kind of telling you this a little bit. How is that data going to answer your question? And then how are you going to evaluate the data that you get? Like, is it valid? Is it valuable for this particular scientific question? That's science practice 4. That's part of the expertise we're hoping you build from some of the labs here in AP Physics. Science practice number 5. Once you've got the data, what does it tell you? How do you know that it tells you that? And do you trust what the data is telling you? Or do you think that you probably ought to gather more data or augment the data that you have with some other information? So can you refine your observations? Can you refine your measurements? And then basically, can you answer the question that's been posed? All right, science practices. Now on to equipment. What are we going to use for this lab? And how do we suggest you capture that data? All right, the Tomy Push'n Go Toy looks just like this. There are some other ones that look a little like this, slightly different, but still comparable. And when I push down on the top of the toy, energy is stored in a spring. That spring engages the wheels, and the wheels spin. That's energy. We haven't talked about that in physics yet, but you can imagine it's energy stored in the spring, which then gets delivered to the wheels. Notice too, or engineers have noticed that a lot of the tread that they put on these wheels when it's shipped from the toy factory wears out over time. These toys were manufactured in 1991, so they're getting kind of old, but still a classic. How are you going to either make sure that your experiment duplicates a new toy or current toys that Tomy is making, and then how are you going to basically be sure that your toy is valid throughout the lifetime of this tread that's on this tire? Once again, to make myself clear, toys get purchased with tread on them and work great. Over time the tread wears out. Is the toy still safe to use? That's your question. All right. Next, the tape timer. I'm going to show this in some detail so you don't have to worry about it right now. But the question is, this tape timer produces dots on paper as paper is pulled through the timer. If I pull the tape faster, is the distance of the dots less or more? If I pull slower, is it less or more? Those are some questions I want you to think about, and you'll basically have the answer once you see the tape timer in person. The dots are made by a little flapper that goes up and down. The flapper hits some red carbon paper, some red marker paper, and the important thing to note is that the flapper makes a dot every 1/60th of a second. So pretty fast. We are sampling, is what it's called, motion, still discreetly, like every measurement is independent, but we are sampling rather fast, so be prepared for that. So I'd like to illustrate now using 3 videos what the lab setup is going to look like so that we're ready when we get to the lab. We're not going to do the lab today, I should just note, but probably during the next class period. So I want you to come to the next class period prepared, having looked at these videos for what you need to do. So please take notes or note any questions that you may have for this video. Here we go. So when your apparatus is set up correctly, you have the toy car with the paper tape taped to the back. The tape goes through the black clip. It goes under the metal hammer and above the red carbon paper. It also goes above the white disc. So here's the white disc here. Here's the red paper, carbon paper, and then here's the clacker. So the clacker goes up and down electromagnetically. So when you're set to go, it looks like this. Okay, so that was a quick look at the setup. You need to be set up every time you take some data. You need to also have a long enough piece of white paper so that the car doesn't run out in the course of the experiment. Video number 2. Now that you've got your experiment set up, how do you take data? Here we go. So now that we're set to go, let's review the steps to get going. I first need to turn on the clacker, and you should hear it bouncing up and down. Sorry to turn sideways there, here we go. If it's going up and down, you should be able to maybe stop it like that. I want to push the top down on the car, and then I want to let it go. When the car gets done, I want to turn off the clacker, and basically the car has gone a certain distance and the tape has been pulled through a certain distance. Okay, so that's one trial. What does that actually do? That's what we're talking about next, but that you have just taken some data with your toy car. Now, what does that data look like, and how does it basically work? What does it look like? Here we go. Okay, what I've done, I've torn the paper tape after pulling it through a little ways, and I'm looking on the underside of the paper tape. So the marks come out on the underside. So I've turned over the tape, and here's what I see. This is what happened when the car had stopped. We have a lot of little red dots all together. If we move along the tape, we see other dots. Let me slow down for a second. All the way along the tape, we have little red dots until we get to the car end. Okay, so first question is, what does it mean when dots are close together? What does it mean when dots are farther apart? That's for you to think about between now and the lab. Okay, we'll talk a little bit more about what you need to do with the dots. It basically involves taking a ruler and measuring the distance between the dots. So the distance will be centimeters, and the time will be assumed that every dot was produced within 1/60th of a second. So given that, you can calculate velocity, and then given velocities, you can calculate accelerations. That's why we have a spreadsheet. So in your Gmail, right now you can check, please do. Yesterday I sent you a link, or earlier this morning I sent you a link to a sample lab write-up. You can use this lab write-up to type up your lab. You can use that Google Doc. Please take a minute, pause this video, make sure you got the link, make sure you can get to that document, and if you did, you can start editing. You can start working on the lab right now. You know what the purpose of the lab is, what some of the equipment is, and then what some of the procedure is. And I should say, if you did not get the email, please send me some email. And if you didn't get the notification of this document, the lab write-up document. Also in the email is a link to the spreadsheet. So the Google sheet you should make a copy of so that it's in your own Google Drive folder, or especially next to your lab write-up. We're going to review that sheet when we're together again and talk about some of the calculations that need to go in that. The calculations have been something that we've covered in class already, so you should be fully up to speed on what you need to do. And we are not going to do the lab today. I mentioned that before. So the data is going to go in the Google spreadsheet. The graphs, some of the interpretation of the data is going to come back into your lab write-up. And then some of your conclusions are going to be drawn from the graphs and from the data that you have. Now then, there is some time remaining in class today. Here are some things I would like you to be doing. You can start the lab right up, as I've said, pair off into your teams, and work together on that. Then, please review the equipment and procedure videos in this video. If you're done with that, your lab write-up is good. In other words, if I go to your folder tonight and I look at your lab write-up, I want to see some progress that you made from class today. Then I also want to see, let's see, some progress. So in our next class period, when we're back together again, I'm going to give you a quiz on the lab before we get started to make sure you understand some of the key details for this lab. So please review this and make sure that you could do the lab right now if you had the equipment. Then, if you still have time, I'd like you to experiment with the PhET simulation from phet.colorado.edu. I've downloaded it. It's on the Q drive under Weisenfeld Physics Moving Man. Please experiment with what constant velocity, constant acceleration, constant distance look like on a graph versus time. This is going to be key to our understanding what graphs we get out of this lab. And then also, if you have questions or things that you've been holding on to, please let me know. Jot them down, put them in your Google Doc at the end or something. Send them to Mr. Weisenfeld and we'll cover those when we're back together. So, that's the presentation for today. That's the video for today. Thank you for your attention.